Hello, this is Mr. Stansbury. I'm going to take you through the notes on Pearson's product moment correlation coefficient, which is related to, which is shown as R to the P. At the end of this, you can say, I can calculate and interpret Pearson's product moment correlation coefficient. Okay? So, for a set of n data given as ordered pairs x1, y1, x2, y2, so forth and so on, all the way up to the last piece of data, Pearson's product moment correlation coefficient is R equals, and it's this big, lovely equation here. I'm going to give you a hint right now. Don't write this down. I'm going to show you a nicer way. But here's what it is. You want to understand what it, how it works here. It's this E here. Remember, is the sum. So the sum of all of the x bar is the mean, so that's the average of all the x's. So if you take x minus the average of the x's, multiply it by y minus the average of all the y's, you multiply those two things together, and then you divide them by the square root of x minus x bar squared and y minus y bar squared. That will give you the correlation coefficient. Okay, x and y are the means of x and y data respectively, and this here means the sum over all of the data values. Thankfully, we can do this on a calculator instead of doing it by hand. You can do it by hand, but it takes a long time. And on your IB tests and everything, you can always use a graphing calculator. So we are going to learn how to do that by a graphing calculator. Okay. I'm going to explain what the R values mean here, and then we're going to jump into actually doing one of these. Okay, the values of R range from -1 to +1. Okay, the sign of R indicates the direction of the correlation. So if it is positive, it goes up. If it is negative, it goes down. Okay, an increase in one variable results an increase in the other. That's positively correlated. And the negative value for R indicates the values are negatively correlated, as an increase in one variable means a decrease in the other. Okay? If R equals 0, there's no correlation between the variables. The size of R indicates the strength of the correlation. Okay? A value of R close to +1 or -1 indicates a strong correlation, and a value of R close to 0 indicates a weak correlation between the variables. Okay? There's a nice little chart here that shows you all of those here, and this is in your text. The following tables are a guide for describing the strength of linear correlation using R. So R equals 1 is a perfectly straight line. If R is less than 1 but greater than or equal to 0.95, it's very strong. 0.87, so you understand here. So this is a strong, moderately strong, this is weak, and then this is considered very weak. Okay, even though that looks like that would almost be 0, but they're saying that it's, if it's from 0 to 0.5, it's considered very weak. Okay, and then same thing over here. These are the positive correlations. These are the negative correlations. Okay, now let's take a look at an example here so that we can better understand that. But before we do, let's take a little comedy break.
Hey, here's something I don't think a parent has ever said. The kids are upstairs playing with all their old Happy Meal toys. I don't think a McDonald's Happy Meal toy has ever made it to sundown. Usually they break as you're taking them out of the cellophane. What is this? Oh, it's broken. Toss it into the trash receptacle. Even if you do get it to work, you never want to do it more than once. So what happens? You push this button, it shoots at 4 inches. Throw it in the trash. Somebody shut that toy factory down.
Okay. Example 2. Sarah has noticed that the number of Doodlebops concert tickets that are sold in a city has an impact on the number of Doodlebops toys sold at the local toy store. Following data was collected. Doodlebops concert tickets sold and Doodlebops toys sold. Okay, so sketch a scatter diagram for the data. Okay, so this here is going to be our X. This here is going to be our Y. Okay, so when we sketch our graph here, this here is our Y, there's our X. So X is our tickets in thousands we'll put. And then this is the toys also in, say, thousands. Okay, so we're going to sketch a scatter diagram for the data. I put this little zigzaggy thing here because we didn't want to start at 0. We're probably going to start at, it looks like our lowest number here is 15. So let's do that. Let's do 15 here. And then we need to go all the way up to 27. So let's go by, I don't know, let's go by like say 3. So this is 18, 21, 24, 27, 30. Okay, you're going to definitely want to label your numbers here and then also make sure that you give it a relatively accurate scale. Meaning that like this, if this is a distance of 3, this can't be a distance of 4 and then 5 and or 8, or like you want it. We went up by 3 each time, and then also this distance should be about the same. Okay, and same thing for the toys. And then again, it's just a really good habit to get into to always just give your graph a title. And so I just call it Doodle Pops, tickets, and toys sold. It's just a little relationship between the two here. Okay, toys. Let's see. We go from 1,000 up to 2,000. So let's do this. This will be 0. Excuse me. This will be 1. Let's do this because we want this top here, up here to be probably about 2,000. Oh, that's toys in thousands. So let's put this as 2. This is 1. We can even put like little lines in here in between. That'll be 500, 1,500, so forth and so on. So let's see. First one here, we're going to go 22, basically 22 and 1,600. So here's 22 and 1,600 would be roughly right here. 15 and 1,000. So there's 15 and there's 1,000. Again, this is just kind of a rough graph. You don't need to go through and measure this all off. 27,990. So that's 28 and 2,000. So 28 and 2,000 here. And then this is 15 and a half and about 1,000. 15 and a half and about 1,000. So that's right about in there too. And let's see, 18 and about 1,300. So here's 18 and that's about 1,300. So about right there. That would be our 1, 2, 3, 4, 5 pieces of data that they gave us. Determine the correlation, sketch a scatter plot diagram for the data. Done. Determine the correlation coefficient R. So here's where we use our graphing calculator. Okay, so graphing calculator, this is a TI-84 plus CE, whatever that, but this will work on an 83 and the 84. So 84 is what you really probably want to try to get if you can. Anyway, so here's what we want to do to figure all this lovely stuff out here. We want to go into stats. Okay, so we'll do stats, and we are going to edit our data. Okay, so right now we have L1 and L2, and there's stuff in there already. What we're going to do is we're going to do this X here is going to be L1 and this Y is going to be L2. Okay, so right now we got a bunch of data in there. Instead of going through and deleting everything, all you do is just highlight the list. Oops. There we go. Oops, did it again. Okay, so you highlight L1 and then you push clear. Not delete. Don't push delete. Push clear. If you push clear, currently nothing happens until you go down into that and all the data goes away. If you delete it, then you lose the L1 thing and you got to reset your calculator. And just make sure you push clear. Push clear, go down, and all the data is gone. Okay. Now what we're going to do is we're just going to simply enter in all of these into list 1 and all of these into list 2. Okay. Once you put everything in, now we're going to go through and we're going to figure out what our R value is. Okay. So we're going to go back into stat and we're going to now calculate. So stat and then calculate. Okay. And then these are concert tickets and toys sold. So we're going to want to go down to number 4 here, linear regression. It's going to take this data here and try to force it into a straight line. So we go down to lin reg, ax plus b, we push enter, and it's going to give us, most of your calculators will give you this. If not, it'll just go straight to the calculate here, and we're like, our x list was in list 1, our y was in list 2, frequency list we don't have to worry about, and then we do calculate, okay? And when you do calculate, it gives you this here. Now there should be an R button, or an R value down here, okay? Mine doesn't have it. And if yours doesn't, here's what you want to do. What we got to do, and this will happen with a lot of calculators, especially unless you've set this up ahead of time. So I purposely left this out so that you would have to set this up. So we do this second catalog, and then we're going to go down to the D. So actually, if you push this button here, it'll kind of helps down. We're going to do diagnostic on. Okay, so there it is. Oops, went past it. We want to do diagnostic on, so we push enter. And right now it says diagnostic on, and we want that to happen, so we push enter again, and it will say done. Now when we go back into mode, stat, we go over to calculate, and we do our linear regression. Push enter, and then enter down here to calculate. Now it gives us the R squared, and in this case the R value is what we're looking for. So it's 0.998. So determine the correlation coefficient R. R equals 0.998. Okay, so we have determined the correlation coefficient. And then the last thing is determine the correlation between tickets sold and toys bought. Okay, first off, it's positive, so it is positive. And we're going to go that this looks fairly linear, positive, linear. And then this is definitely 0.99 is definitely strong. Actually, the book would call it very strong, so maybe let's put very strong. Very strong. I think you'll probably be fine with just putting strong, but that was from that chart that we had on earlier. Okay? All right, that's all we have for Pearson's product moment correlation coefficient notes. If you have any further questions, please feel free to ask. Thanks.